Okay, today's lesson is 11-4A from the central limit theorem. It's A because we're just concentrating on objective 1, using the central limit theorem to find probabilities. Okay, so to continue what we've been discussing, all right, just to give you an idea of the overall objective of what we're doing. Okay, we need to tell you what a sampling distribution is and define some words. So a sampling distribution is a distribution of the means or averages of random samples of a certain size that are taken from a population. Now, the standard error of the means is also known as the standard deviation of the sample means. There is something called a sampling error, and that causes differences between the sample means and the population means, because the sample is not a complete representation of the population. So what you're going to find out when we're doing these is we have a normal way of doing it when we are just given our information, but if we are told that we are taking a particular sample, then it changes our formula a little bit. So this is what we have, all right? So we've talked about in the last lesson how the larger n gets, then the closer it is to the population, okay? But basically, we have the same information that we had before, okay? Mean is represented by the letter mu. Standard deviation is now going to be the standard deviation divided by the square root of the sample size, okay? So this is the same thing that we had before, mu and sigma, but now when we're told that we have a sample, we're going to divide by the square root, okay? The z value is the same, and that's the same formula that we had before. They're just using the information from your sample, but I'm going to show you how we're going to do that again with ClassCalc, which makes it really easy and means you don't have to calculate a z-score. The z-score was needed because we didn't have calculators before that would do this, so you had to use a z-chart, okay? So if you had the z-chart, then this is the information you have. You had to go figure out a new standard deviation because of your sample. Actually, I have to read the problem first, my bad. The average numbers of tornadoes in Kansas is 47 per year, with a standard deviation approximately 14.2 tornadoes. If a random sample of 15 years is selected, find the probability that the mean number of tornadoes is less than 50. Okay, so I have a sample here, and because I have a sample, that affects my standard deviation. So I take the original standard deviation and I divide by the square root of the sample size, and I get that number. Then, if I'm looking for the mean number of tornadoes that's less than 50, then I would put it into my z formula and get a number, round that number, and this is what you could put negative infinity to 0.82 with other graphing calculators, okay? And when you did, your calculator would spit back at you that number. And I draw the chart just because I think it's helpful for people to understand. When they say that mean number is less than 50, then you're taking that z-score. Remember, on a normal distribution, the mean is 0 and the standard deviation is 1. But as I said, if you don't have a calculator or don't learn how to use ClassCalc, then you have to take this number and you have to go put it into your z-chart. And you will get 0.7939, which is pretty close to that, and that's acceptable. So if we were answering the probability, then we would answer it as, my answer is going to be 79.3%, okay? But if you have something that is 79.4%, that is fine also, because I know you're using the z-chart. Now, let me go refresh your mind on how to do it with ClassCalc. So with ClassCalc, and I'm going to do this, I'm just writing it down so you have it handy if you need it. We're going to go into the graphing. We're going to hit stat. We're going to hit distribution plot. And then we're going to hit normal distribution. And it's going to ask us, what is our mean? 47. What is our standard deviation? I have a sample, so it's the same thing we had over there, but you don't have to actually calculate it. I'm going to put that into ClassCalc. And then, because I want those less than 50, then I push the CDF, which brings up this information to put in. And just like I did over here when we had negative infinity to 0.82, actually, I mean, it's the same kind of interval thing, but we're going to have negative infinity, and we get to use the problem in the chart. So I am going to go do that real quick, and I need to make sure that I have ClassCalc up, so give me 1 sec. Good thing I checked. Okay, so here is ClassCalc. So I want to point out to you, so anyway, okay, so what I said was go to Graphing. We're going to go to Graphing, and I'm on the Graphing tab. I'm going to hit Stat. Come on. I'm going to hit Distribution Plot. I'm going to hit Normal Distribution. And I'm going to show you, you can do this same thing that we just did, like the very first time. The one that I did on this side here, you can use it with that. If you're so insistent and want to use the z-score, you can put in a mean of 0, a standard deviation of 1. And remember, after you do that, we push enter, and then we push the magnifying glass to see it. And I like to zoom out so we can see it above there. And then I'm asking for the tornadoes that are less than, the probability that the mean number of tornadoes is less than 50. So I had to put in my chart, and I made it negative infinity to, but we found the z-score, and the z-score was 0.82. Okay, so if I put 0.82, that's where they're getting that number off the chart. But if we didn't round it and our normal z-score was that, you can see how it's closer to what it is. So I say that because the z-chart is rounding the numbers because they have to, because they have a limited amount of space that they can put things in. But I'm going to show you how much easier it is when we do it with, if I come up here and put it where I don't get a z-score, I just go straight up. My mean was 47. The standard deviation was 14.2 divided by the square root of my sample size. So I'm putting it in just like that. It's the only difference that I have. So I'm going to hit enter to graph. The magnifying glass will bring it up. So same kind of thing we had before. And I want to know those that are less than 50. So I'm going to type 50 in. When I type in 50, there's my number of 0.7933. And that is what we have here, 0.7933 or 79.3%. So I'm going to go through the rest of the problems. I'm going to have this worked out. So all the way through here, the blue is going to be going with ClassCalc, and the purple is if you want to go and use your z-chart. And I will have the z-chart somewhere on the calendar for y'all to use if you want to, or you can Google it and get one. Okay, so this says find the average cost of a gallon of milk in a U.S. city is $3.49 with a standard deviation of 24 cents. If a random sample of 41 gallon containers of milk is selected, find the probability that the mean of the sample will be between 340 and 360. So the difference here, again, because we have a sample of 41 gallon containers, then I have to change my standard deviation to accommodate the sample. And then because they asked me for the mean between 340 and 360, you would have to go calculate two different z-scores. And that would be the chart. I'm looking for what's in between those two numbers. So you would put that in your calculator. On ClassCalc, again, mean of 3.49. Standard deviation is 24 cents divided. So this is the same, okay? This is the same for both of them. This is what's different. You have to go do this extra work if you did that. And then you would go use the mean of 0 and the standard deviation of 1. But I got a mean of 3.49, standard deviation, whatever that number is. Well, you can see over to the left, it's 0.039, but I'm not going to worry about it. Then I'm going to put CDF, and I'm going between 3.4 and 3.6. So I'm going to go back to ClassCalc, and I'm going to clear that and clear that. I didn't have to, well, I could have just typed over it. Probably should have done that. Stat, dist plot, normal distribution. Sometimes it helps to see the buttons. So my mean was 3.49. My standard deviation was nope, that was the last problem. 0.24 divided by the square root of 40, my sample size. I'm going to push enter. I'm going to push the magnifying glass to see it. And then I'm going to go push CDF, and I want to know what it is, the probability of the price between $3.40 and $3.60. And I 0.24 divided by 40 is 0.9893. So let's see what I get. So there, if you put it into the calculator, you get 0.9892. Again, it's a rounding issue. This one was 0.9893. Both answers are giving you 98.9%. So if you were putting it in and you round to the nearest thousandth, you would see 0.989 and 0.989, either one. So when you do your lesson check, you can read the directions. If they tell you to round to the nearest thousandth, you put the decimal. If they say you can put the percent, you can, but you have to put the percent sign if you're going to use percent. Okay, last problem, kind of doing side by side so you can see how it's affected. Consumers in the U.S. eat an average of 19 pounds of apples per year. Assume the standard deviation is 4 pounds and the distribution is approximately normal. Find the probability that a randomly selected person consumes more than 21 pounds of apples per year. Okay, so 21 pounds with that information, putting it into your z-score. They said more than 21 pounds, so I'm putting that z-score on my chart and putting it in the calculator with ClassCalc. Okay, and this is what I want you to write down on your work so that you remember what to do. But your mean is 19, your standard deviation is 4, CDF, what am I looking for? Even on my chart, you can tell from up there, I want it from 21 to infinity. So we're going to go do that. So you can just get a lot of examples and make sure you know how to do it. So I'm going to clear that. And, I should have just typed over the numbers. I said that last time. Stat, displot, normal distribution. My mean is 19. My standard deviation is 4. Push enter. I want the magnifying glass so I can see it. I hit CDF. That's funny that has both of them on there. CDF, and it was going from 21 to infinity. So what is my answer? 0.3085. So, well, that's what we got right there. So I put that down and I change it to a percent. Okay. What's different about part B? Part B, if a sample of 30 people is selected, find the probability that the mean of the sample would be more than 21 pounds. So it's the same problem that we have here. The only difference is that I have to divide it by 30. I have to divide my standard deviation by the square root of 30. Okay, so again, just giving you the calculations for if you want to do the hand calculations and use the z-chart. If you want to use ClassCalc, that's the only thing that's going to change. We're still going to have these numbers. Let's go and let me show you how easy it is to change that. All I have to do is come up here and put my cursor behind the 4 divided by the square root of, what was my sample size? 30. Okay, so this time, because this didn't change, that was the only thing that changed. So make sure you read the the problems closely when you take your lesson check. But it would really help for you to do some new problems and practice those homework problems. That is 0.003, which is really, really small. Okay, so just keep in mind and making sure you know that decimal was 0.003. I just added some more, but if you had to round it in ClassCalc, on your lesson check, you would put 0.003, or that, of course, is 0.3%, because you just moved the decimal over 2 places. And that is all that there is to 11.4a. I hope you thought it was easy. I hope you practiced with ClassCalc, and come see me if you have any questions, or email me. Thank you so much. Y'all have a great day.